Hello, welcome back to another awesome project. For those in the know who can see what's in front of me, they already have an understanding of what we've really got here. For those who don't know, Hickok is accepted as an industry leader in consumer grade tube testing equipment. This is the 6000, and it is pretty much functionally identical to the 6000A, except it doesn't do transistors, which I really don't care about, and it doesn't do the like funky late model tubes like the new Vistas and stuff like that. Other than that, we have pretty much the same thing with less circuitry and less to go wrong. This is going to be a full restoration, full calibration, and we're going to open this up, see what's inside, and maybe this will also be a practical discussion in this ongoing saga about the Type 83 tube versus the solid state replacement for the Type 83 tube. There's a lot of discussion about that, so let's dig into this. We'll get started. And of course, I already opened this up, but I'm going to open this up if for dramatic effect and show you how I found this. I didn't fix anything, so just to show you what we're up against here. That's what we're up against, and with all the screws being in place, it looks like the wood that holds the unit in place has broken off of the sides and knocked the unit down on this side, right? But what I'm going to do is we're going to do an inspection of the case first. We're going to take a look at that, and then we're going to dig into this. We're going to get it out of the case anyway, so the case will be repaired separately anyway, and that's how we're going to proceed. So the covering, the pleather covering for these cases are never in good condition, because this was a tool that was often carried by technicians around and banged up in cars. When you see something like this is actually very nice, If you really wanted to go nuts and recover these things, you could. But this is what you would call for this cover extremely nice condition, in my opinion, right? Looking at the rest of this case, which bears the brunt of the attack, I see structurally, it looks like there's tape here. I don't know if it looks like there was some sort of repair that went on over here. Either way, again, this is not an item that I'm overly worried about, those sort of things. I'm just looking for structural issues, and I'm not finding any here, right? I do see one here. There is a structural issue here that will need to be looked at once it comes out of there, and a structural issue over here, right? It looks like a dovetail separator or something. I can't get a good look in there just yet, right? But I will once the unit comes out of here. But all in all, it looks like it's broken at seams, and it can be replaced. The latches are in good condition. The handle's in good condition. The boiler plate's in good condition. So overall, things can be fixed. It's not a write-off by any means. So that's my initial inspection of the case, and we're going to take the unit out now. I'm going to remove the screws that prop up the broken side first, obviously. Now it's safe to separate this unit from the case. I don't know what kind of carnage we're going to have inside. Yeah, and the frame broke, that's all. Luckily, it didn't collapse on the tube side. It just collapsed on the meter side, and it was held up by the switches, so there's no damage. So here's what happened. All of the nails got knocked clean out of the wood that holds this up. Took quite a hit, obviously. You can see that got knocked out here, and that got knocked out here. Luckily, this one managed to stay up, and this one managed to stay up partially, and that's what saved the unit, right? So this is very easy to repair. I'm going to knock that back into place. Before I knock that back into place, I want to see if anything is broken over here, or if that just got bumped, right? Make sure everything's fine with this. I've been adding epoxy to those holes and nails, right, on a toothpick, so that once it dries, it's not going to be like I'm just putting the nails back in the holes and they're going to fall out again, right? So I'm taking some preventative measure here. And it doesn't really need to be hammered back into position. You push it really hard, gets it back in a position. There we go. And that epoxy will harden in about half an hour. And those things will be back in there nice and good. So we'll let all that dry. Should be good to go. With the wood fixed, I'm now working on the corners. These are the staples that I pulled out, and they were causing the wood to bend outward as the staples were already ripped out and just sort of stuck in the wood sideways. So now I'm replacing those staples in the correct fashion. I was able to tap it really gently while I push the wood and get it right back into the original hole. I probably put just a little bit of epoxy right there just to seat it. So now I've tied the torn fabric back together and folded it over with some epoxy very sparingly. Right now it's wet. I'm going to wait for it to dry, and that should stop any of the fabric from tearing. It doesn't have to look showroom quality, but I can't have it ripping past this seam. This should do the job. So I'm going to have this dry. The wood's repaired. There's probably a sliver of wood that used to be from here to here that got cracked off, so there's a slight indentation there. I'm not overly worried about that either. So I'm going to walk away again another half an hour, see what this looks like when it's dry, and then I'll continue on to the bottom half that's cracked. This piece has a large broken off splinter of wood that I want to glue in first before I do anything else. So I've got that piece epoxied in. I'm going to let that cure while I have it clamped in place. We can see that it bonded very nicely. Everything is set up good, and now we can repair the fabric around it. Just so I don't have a dip on this side, I'm just going to drop this toothpick in here, and that should stop any dip from forming in here in the fabric, right? And that's going to fill in with whatever epoxy I put in there. Having filled the area and applied the epoxy around it, I was able to now close the fabric, and I'm just going to let this dry. So I took out the island. I just wanted to have a look back here and be absolutely sure this was an 11 pin, and I expected it to be. The 6000A is a 12 pin, and it tests tubes with a larger number of pins on it. Obviously, it has extra pins, right? The thing that interests me on this, not really interests me, but it just got me curious, is this and this right here, because it looks to me like transistor tester of some kind, and I don't believe this supports transistor, and it makes me wonder why this is on here, or if this is originally for this unit. I know it's an 11 pin, right? But I don't know if there was like a model in between where they started to support this function for the 6000 and therefore had one of these. If they don't, I don't care, right? Because I don't care about testing transistors on this thing. It's just something I found curious, and therefore I wanted to be sure that it was in fact 11 pin and this wasn't a kludge. And then I verified this again by looking in the schematic diagram. And the schematic diagram does reassure me that everything is copacetic, though it does reference the original connectors on here. I see that there is in fact an inline, right? And that's when I started saying to myself, oh, I didn't notice that, but I'm going to have to see what that application is for, right? Because the fact that it is mentioned specifically there, there has to be value in that. I'm just trying to figure out exactly what that is. I'll just note for the record that on the island, pin 11 is the only pin not used. There's just nothing in it. Having finished all of the case repairs, it can now be used as a stand to service the test set from the other side. Well, look what we got here. This was 50 microfarads at 6 volts. You know that's garbage, right? That's gone. Then we got here, what is this? 5.5 microfarads at 200 volts. That's most likely garbage, and that's going to be gone anyway. Got two tubes here. We got the 5Y3 on the right, and the ever famous Type 83. Ooh, and look, it's loose. We're gonna have to repair that. This is one of the most contentious parts of these tube testers, as a matter of opinion, and this is going to become an important topic as part of the calibration, so stay tuned for more on that. One thing everybody agrees on, though, hands down, is the first thing you do with this unit is you remove the paper roll with the test data and put it somewhere safe before you do anything else. And in this day and age, when everybody agrees on something, you generally do it, because nobody agrees on nothing no more. I'm going to state, though, that actually the first thing I'm going to do is remove these tubes and then flip it over, because I don't feel like breaking a tube for nothing. Basically just dumped a bunch of super glue down there in a circle as to not get anything on the sides, really. With that, now it's safe to remove the test data roll. With the test roll removed, they don't have to worry about damaging it, and yeah, there's less to deal with, which always makes things easier. I have the 2 capacitors that I need. I'm going to have to try and find the outer shield of this one, though, using the oscilloscope. You know, things are getting out of hand when you have to stop and repair your tube tester while you're repairing your tube tester, so yeah, it is what it is. I've got the first capacitor replaced, that's done. I started testing the other one. I could see no outer foil difference on this cap, regardless of which side I flip to ground. I see the same amount of noise, so I'm just going to put it in and not worry about it. Now I've got the second cap replaced too. I've put a little bit of cardboard under that holder in order to be able to securely hold this new slightly smaller diameter cap. My 912 was not ready for show by any means, but this is all I got to test that 83 tube. So I'm bringing it up now. I was able to get the settings to test the 83 tube, so I'm going to have to set that up right quick. And here we go. Getting just about the same reading on both sides. That's a good sign, right? Yeah, so very happy with that. I think that concludes the 83 testing. I believe the 83 is actually doing pretty good. While I got it up and running, I'm just going to knock out the 5Y3 as well. This is on C and F for both plates. On this test set, that means it's good. Had the short light come on F. That's not good at all. So now I'm going to have to take a look with the other tube tester, make sure it's not this tester. Either way, I'm going to pull it out, check with the other tester. If not, I'm going to have to replace the 5Y3. Damn. I've switched back over to the Sentry to test the 5Y3. I got it heating up right now. So far on the first leg, I don't see any shorts or gas lights on, so we'll see what happens. And this side shows good. Now moving to the other leg of this tube, letting that warm up now. Again, I don't see any shorts or gas. And that side is good. Yeah, it could be the tester. It's an unrestored tube tester. Just seeing what I could get out of it, and this is good. I re-terminated this capacitor only because it looked terrible and it bothered me. So there it is. We get to one of my least favorite parts of this project, and that is the deoxit. I'm going to start with the island. I have this tube socket cleaner, right? So we'll get started now. Tell you, some of these sockets feel well used. I may be able to get some life back into these, but look at the test. I mean, wow. And they can be replaced if you have to. It's just that I'm trying to avoid that if I don't need to. Over here, there it is. This socket seems pretty good, a lot better than the one for the 12AX7. 12AX7 one may need a little bit of tweaking. Let's see how the 4-pin is doing. We use our rectifier for the 4-pin. I think it's over here. Yep, that fits nicely. Very good. There we go, that should do it. I went in and retensioned the pin socket for the 9-pin right here. A lot of times you get people ripping them out in one direction, and it pulls these there's actually two metal sleeves that are separated. It pulls one away from the other, and then they're just so far apart there's no tension anymore. Now, pushes in, there's no wobble anymore, right? And pulls out nicely. So that fixed that right there, and I figured that all it was needed. As long as you don't treat it like crap, it should work just fine, not require any further repairs. Next part for the deoxit's going to be these two tube sockets. I'm going to use the brush to clean them, so I'm just going to pre-hit them, just like that, and the brush. Then I'm going to do each one of the sockets with the brush. Those sockets are now finished. On to the next task. Again, continuing with the case removed and the test set on the bench so I can lift it like this. I will start with the deoxit on all of these bottom switches one at a time. It's really boring, and it kind of goes like this. Spray it like that, lift it up, and run through the entire range of motion like 10 times in both directions. And then sometimes I just give it another little blast for good measure. Then the next switch. Now the whole bottom row is completed. I'll move on to the next, which is this group of push buttons right here. But these push buttons are spring-loaded switches. I can see the contacts too. Hit the springs also, and the metal. And gravity will work its way down there. Now these switches are all finished. I have a multi-gang rotary switch over here, so I'm gonna have to hit it in multiple sections, under and over. I have to see how many sections there are. Way back here, I have, it looks like a 2-gang potentiometer. This is the shunt control, and I want to get some deoxit in there. In both of them, spray it, clean it, let it drain. Just like that. I want to have it on its side when I turn it so it doesn't leak out. Bias one is right here. It's open wire round potentiometer right here, way behind the transformer, right? You can see it. I think the bias is it. I can see it's a very like self-cleaning mechanism. I wouldn't see any oxidation form in there that wouldn't be cleaned off simply by turning this mechanism in a way that I could evaluate it. So I'm not going to spray any on there. I think this one will be fine. Line adjust is another one way down here. We can see it's an open wire wound resistor, and it's a tension spring, so it would be self-cleaning as well. If there was a problem with it, I would come back to it, but I'm not going to spray any deoxit on that one either. Finally, way down here under the transformer, we have the voltage selector switch, and this one will need to be cleaned as well. These are the calibration pots. While I would obviously clean them, I'm not going to clean them until after the turn up and test, before the calibration is done, right? So I want to see how everything's working right now before I break the seals. And then during the calibration, I will clean the pots and then set them. Right here is another calibration pot on the meter. And that concludes the deoxit step, which brings me to the next step, and that's going to be resistor checking. Very light cleaning on the fuse / light bulb. That's it, and put it right back in the socket. We'll do a provisional check of this unit now. I'm going to put the tubes back in the socket and put this back into the box, and this will allow gravity to drain out the remainder of any deoxit that I've sprayed in here. These things are kind of a pain. Take a last opportunity to spray the last piece. That's the connector. Just like that. Just gonna hit that piece. And with that, I'll reinstall the island. I've also cleaned the holder for the bias fuse, which is just a lamp. Put that back in. Now that the island is connected, there's going to be some detail work done on the top of this. Probably remove this nasty looking tape too when I get to it, but that's not important now. I'm not putting the roll back on yet. That's not going to be done until after calibration's finished. It also makes it easier to remove this from the chassis. We can see the tubes down there for inspection. This device is ready for a power on test through the Variac and isolation transformer, except there's one more thing we got to look at. This is not a showstopper, but I got to know. So, I mean, I can see the plug is like cracking, but I got to see the extent of this. Is this just the outer shielding? Right, and it's very strange because everything is very supple except the end. And I could actually just put an end on here, a replacement end. But it seems like the cable inside is okay. So we're gonna monitor it on the Variac. We'll make sure, and I'll test it for shorts, make sure everything's fine. I'm gonna put that tape on for now. And ultimately what I'm just gonna do is I'm gonna pop a new 2-prong head on this. I notice that the bias knob extends beyond 0. And when I turn it to 100, it falls short of 100. So the knob is off balance here. So there's a screw right here. I'm just going to make that adjustment right quick because I know that that's wrong. And there we go. Stops at 0. Stops at 100. I'm going to go out on a limb here before I start anything and say that the static 0 should probably be here. I think I'm just going to set that. The first test that we're going to be doing is the power line adjust. And this is the, we're going to turn on the power and we're going to have the meter move up on the scale adjust control until the meter rests exactly on the mark. Line test at the center of the meter scale. This establishes a standard voltage on the tube to be tested. Make sure final adjustments after the tube to be tested is placed in the socket, right? So that's all we're going to do right now. And I am bringing this up on a Variac, so we're not immediately coming to full power here, but I don't want to bring it up too low. Just making sure it's not smoking. I'm seeing deflection. I want to get a voltage reading here of 80 volts. Yeah, it's looking good. No excessive current draw. 90. Variacs are really iffy if you're going to hook it up to a tube tester because Variacs will drop. Let's start raising the line voltage on this. And bring this up to 120. So I don't want to keep this tube tester on the Variac very long. There's 120 in and about, right? And now I could take the line adjust and get this up to a line test, right? We could see that meter move there. We could also see that all of the short lights are on. That's good because all that means all the neons are working. So the first test is a success.